Welcome to Study Loop.
This is the answer to Chapter 23, problem number 69 from the Smith Organic Chemistry textbook. This problem asks us to synthesize each of these two product molecules from ethyl acetoacetate and the given starting material. And we're told we can also use any other organic compounds or required inorganic reagents. Okay, so for A, the first thing that we're going to need to do is convert the starting material that they give us to a form that we can use with the ethyl acetoacetate, the synthesis that we know from this chapter. And so to do that, we're going to need to replace that alcohol with the bromine. And so PBr3 does that nicely. So that gets us to the bromide here. Okay, and now we can add that to the ethyl acetoacetate that we have using sodium ethoxide to deprotonate the ethyl acetoacetate, and then we can add in the bromide that we just made. And that is going to give us this molecule. Yeah, so let me redraw that so there's no confusion. Okay, so there we go. Now we're going to need to decarboxylate. So treatment with some aqueous acid to get to hydrolyze the ester, and then heat to decarboxylate, and that is going to get us to here. Okay, and then from here, all we need to do is install the epoxide, and that we know can be done with MCPBA. Okay, so there we go. There is our product molecule for A. For B, we can actually start with the ethyl acetoacetate, since the other starting material that we're required to use is already a bromide. And so we can use sodium ethoxide once again to deprotonate the alpha carbon. And then we can add in our given starting material. Oops. Let me fix that. Drew one too many carbons. Okay, so there we go. After that step, that's what we'll have. Now we need to hydrolyze the ester and decarboxylate it. And so H3O plus in heat gets rid of that and gets us to right here. Okay, and so now it looks as though we need to add one more carbon. But actually, before we do that, what we should do is protect the ketone that we have here. And so in order to protect the ketone, we'll use ethylene glycol. Antoxic acid. Oops. Okay. And that installs this cyclic protecting group. Hopefully everyone remembers from the previous chapter. Let me move this down. There we go. So we've installed that protecting group. Now we can deprotonate our triple bond and make an acetylide type ion. Sodium hydride will accomplish that. And then we can use methyl iodide to add the one more carbon that we need there. Now we need to go from that triple bond to a cis double bond, a cis alkene. And so to do that, we can use hydrogen gas and Lindlar's catalyst. And so that will accomplish that transformation and give us exclusively the cis alkene. Okay, so there we go. And then the last thing that we need to do is just deprotect that ketone to get our ketone back. And so some aqueous acid can accomplish that for us. Okay, and so we fix this. So that's the series of steps that we need here. That's part B. Here again is part A. And that's the answer to chapter 23, problem number 69.